We're going to look at edge-triggered D-type flip-flops. We've already looked at level-triggered D-type flip-flops, so we're just going to look at the difference between the two here, and again just go a little bit over what D-type flip-flops are. But for more detail on how the circuit is constructed, do look at the video on level-triggered D-type flip-flops. As we've seen, D-type flip-flops are used for a controlled delay in a circuit, and they serve as the basis for storing data in memory registers. Now, into a D-type flip-flop, there are two inputs. You have the value of the data itself, whether that's a 0 or a 1, and you have an input clock where the value changes from 0 to 1 at regular intervals. The outputs include the value Q and also then the corresponding inverse of that, not Q. So the output, if Q is 1, then the not Q is obviously going to be 0 and vice versa. Now for edge-triggered D-type flip-flops, when we talk about a positive edge-triggered flip-flop, the output state can only change when the clock moves from 0 to 1. We saw in the case of a level triggered D-type flip-flop, the value could change at any point when our clock was at 1. But now it can only change, our output state can only change when the value of our clock changes in that instance from 0 to 1. If the input data is in the same state as it was on the previous edge, then the output will remain unchanged. If the input data has changed value, then at this point then the output state will change value to the input data. Let's have a look at an example of this now. So we've got a situation where we have our first edge trigger here on our clock in this scenario. Our data value is at 0, and therefore our Q value still remains 0. So our data has remained unchanged at 0. So therefore our output is Q is at 0, and our input clock edge trigger here moves from 0 up to 1. So we'll move on now to the next edge trigger here. So our data now has moved up to is now a value of 1, and at the point where the trigger happens, our value of Q now also has gone up to 1, whereas before that, even though our data value had gone to 1, our Q remained at 0, but at the point at which the trigger of the clock goes from 0 to 1, our value of Q also goes from 0 to 1, so our output goes from 0 to 1. The next trigger means the data that's at 1 stays at 1 for our output. So our input data is 1, so nothing changes there. So then we go on to our next trigger. At our next trigger point, at that point, our data value has gone to 0. So now our Q value at the point of the trigger, but not before, now goes to a value of 0 as well. The next trigger, our data remains unchanged at 0, so therefore our output Q remains unchanged at 0. And again, no change happens at this point. Our data is at 0, our Q is at 0. So you can see here in this scenario, we have a delay between our data value and our Q value. So hence the delay type flip-flop. So that's why it's a delay. That's why we think of it as a way of storing a data value.